So today we're going to cover Chapter 11, Section 1, and we're going to learn how to calculate circumference and arc length. So the first slide has the formula and the definition for circumference. Circumference is just the distance all around the circle. You probably have already seen this formula before in middle school. Whenever they give you a diameter to calculate the circumference, you just multiply diameter times pi. However, if they give you a radius, you will have to times that by 2 and by pi. Now, I will give you this formula for the quiz and for the test because this is a formula that is provided on the SAT. However, the ACT does not give you any formulas, so if you were to get a question like this tomorrow, you would have needed to memorize the formula. Now, keep in mind that this formula, where they give you a diameter, you can also memorize it as diameter times pi, because remember, multiplication is commutative. So it doesn't matter the order that you multiply it. You could either do pi times d or d times pi. Same thing for the formula for when they give you a radius. You can memorize it as 2 pi r, or you could rearrange it times the radius and then times it by pi. When you're doing the homework, you're going to have instructions that are going to say, leave your answer exact or leave it in terms of pi. And what this means is you're not going to use your calculator. You're just going to leave the pi symbol. If it doesn't specify, then what you're going to do is you're going to use your calculator. You're going to use the pi button, and you're going to round to the hundreds place. So if it doesn't specify to leave it exact or in terms of pi, or if it doesn't tell you a place to round to, then round to the hundreds place. So if it doesn't say exact or terms of pi, know you're using your calculator and you're using the pi button. Chances are in middle school, they may not have required you to have a calculator. So what they might have told you to do is use 3.14 for pi. On an SAT or an ACT, they may ask you to do this. Because right now, the current way that SAT is, they do have a non-calculator portion. That is going to change in the future, where the entire SAT will be a calculator test. But for right now, you could get an SAT question where they say, use 3.14 for pi on a non-calculator portion. But for our purposes, we're going to either use our pi button and then round our answers, or if the instructions say leave exact or in terms of pi, then we're going to leave the pi symbol in our answer and not be using our calculator. So really, circumference is like perimeter. They don't call it perimeter, but what we're doing is measuring the distance around the outside of the circle. If in the homework it tells you to round to the tens place, then read the instructions. But if it doesn't specify exact, then know that it's hundreds place, okay? So just read what place they tell you to round to. If it doesn't specify, it's automatically hundreds, unless it says exact. What it means by in terms of pi or exact, let's say I gave you an example, and let's say I told you, find the circumference, and I'm going to give you a diameter with a length of, let me change that to a length of 4. So then all you would do is take your formula, diameter times pi, and then all you do is replace the d with the 4. And let's say that these are centimeters. So this would be 4 pi centimeters, and you're done. So when it says in terms of pi, all you're doing is either taking out the D and putting it in if they give you a D, or if I give you an R, you would take out the R, times it by 2, and then leave the pi symbol. So that's what it means in terms of pi. We don't hit that button on our calculator. This would be an example of leaving it exact or terms of pi. If it said hundredths, then we would use the pi button, and what we would get is 4 times pi. That would give me, rounded to the hundredths place, 12.57. And again, you're going to need to label your answer with the appropriate units. So this would be the same question given a diameter, but using the pi button. And then this would be the answer, leaving it exact, or in other words, terms of pi. So arc length is just a portion of the circumference of the circle. What we're going to be using is the measure of the arc, and this is what we used or calculated in chapter 10. So this was chapter 10, and it was in degrees. Now what we're doing is the length of the arc. So if you think about in this circle here, this little chunk of it, this is like a piece of pizza or a piece of pie. The arc length is how long the crust is of your pie or your pizza. So if you were to cut off the crust and then straighten it out and put it along a ruler and measure it, that would be arc length. So it's measured in inches or centimeters, whereas the measure of the arc is measured in degrees. So for the arc length, when you have a circle, the ratio of the length of the given arc to the circumference is equal to the ratio of the measure of the arc to 360. So again, we're trying to figure out what portion of the circle is that arc length. And we know that a full circle has 360 degrees. Now, you can either choose to solve it using a proportion, which would be this. The formula I like to work with is this one. And I'm going to show you 3 variations of it. Now, when you're doing this, notice in the formula it's got AB. The arc length is not always going to be AB. It could be XY, depending on your picture. So what I'm going to do here instead is put length of the arc, or arc length, is equal to measure of the arc. So instead of putting MAB, whatever arc they've given you, and it could have different letters, over 360 times the circumference. Now, you may not be given the circumference. Maybe you're going to be given an area. So then what we'll do here is the arc length is equal to measure of the arc over 360. And let's say instead they've given you a radius. So instead of putting capital C there, I'm going to put the formula for circumference, which is 2 times pi times the radius. Or, these are all ors depending on your given. Let's say they gave us a diameter. So still arc length, or length of the arc, is equal to measure of the arc in degrees divided by 360. And let's say this time they gave us a diameter. So then instead, I'm going to do pi d here. So the red is what'll change depending on your given. So if you're given the circumference already calculated, then you would just put a C there. If they give you a radius, then you have to times it by 2 and pi as well. Or if it's a diameter, just by the d and the pi. So again, the arc length is like if we were to measure the crust, the units are going to be linear. They're going to be like inches or centimeters or meters. Okay, so for the first example, it wants us to find the circumference given the diameter. Now remember, there's two formulas that you can use for circumference. It's either pi times the diameter or 2 times pi times the radius. They gave me a diameter, so I'm going to use this formula. And left in terms of pi, all I'm going to do is circumference is equal to pi times 5. And then if I want to flip it around, you could leave it like that. But again, and these are inches. This is exact, so this is leaving it exact, or terms of pi. Now, just to go through this, I'm going to also show you the answer you would have gotten if you just times it by 3.14, just in case you see this tomorrow or on an SAT. So if I use instead 3.14 for pi, then I would do 3.14 times 5, and then this would give me 15.7 inches. Now what you'll be doing in the homework, if it doesn't say exact, you're going to use the pi button. And we're going to round to the hundreds place. So we're going to do 5, and then we'll hit the pi button. And then once we do that, you're going to get rounded to the hundreds place. It's 15.707. So rounded to the hundreds place, 15.71 inches. Notice how close we got just using an approximation for pi. But again, this would only be potentially on an SAT or the ACT. What we're doing in the homework is either we're going to leave it exact, which would be this, or using our pi button, which would have been that answer. Just read the instructions. The next one wants us to find the radius. So for the next one, I'm using the formula circumference is equal to 2 times pi times the radius. I'm going to be solving for the r. So I'm going to replace the circumference with what they gave me, 17 pi. I'm going to leave the 2 pi, and I'm solving for the r. Now notice the 2, the pi, and the r are all being multiplied. So what I need to do here to undo multiplication, I'm dividing. Now, if you want, you could divide both sides by 2 pi in one step, but just let me show you step by step. Divide by pi. When I divide by pi, notice the pi's cancel on both sides. So now I'm left with 17 is equal to 2r, and now I just have to divide both sides by 2, and my radius is equal to 17 over 2, and these are feet. However, if it says to round to the tenths place, we would divide, and it's 8.5. So on the test, if I don't specify to round, I would be okay with you leaving it as the fraction. But in the homework tonight, read how they want you to leave your answer. If it doesn't specify, you're rounding to the hundreds place. So the next example wants us to find the diameter given the circumference of 6 feet. So again, they gave me a diameter, or I'm finding the diameter. So I'm going to do circumference is equal to pi d. I'm going to replace the circumference with 16. I'm going to I'm not replacing anything else. I don't know the diameter. This is what I'm solving for. So in order to get d by itself, all I have to do is divide both sides by pi. And the pi over here cancels. So D is all by itself now. So D is equal to 16 over pi. Now, if it said leave it in terms of pi, that would be my answer. But notice the instructions say to use your calculator. So you're going to do 16 divided by pi. And once you do that, we're going to round to the hundreds place. And we get 5.092. So rounded to the hundreds place, my diameter is 5.09 feet. So this is exact, or terms of pi. And then this one is rounded to the hundreds using your pi button. So again, read what they ask you to do. The same thing will happen on the quiz on Friday. I will specify exact, terms of pi, or what place to round to. The next one is a word problem. And it's telling us that a car has a diameter of 28 inches. So let's say this is my tire. And then its diameter is 28 inches. It wants me to figure out how many revolutions, which means how many turns of the tire does it make when it travels 500 feet. Now notice the diameter is in inches, but it's traveling, the units are feet. So once I find the circumference, I'm going to need to convert those into feet. So what I can do is my formula for circumference, since they gave me a diameter, is pi times the diameter. So I'm going to multiply pi times 28. And I'm going to leave this long number on my calculator. I'm not going to round till the end. So once I multiply 28 times pi, I'm going to get 87.9645943. And these are inches right now, but I need to convert them to feet. So we're going to use our conversions that we probably learned a long time ago. You might have done something called dimensional analysis. If you're currently taking chemistry, you probably did dimensional analysis. You should have done it in middle school as well. So in order to convert inches to feet, I know that there are 12 inches in 1 foot. So 1 foot over 12 inches is my conversion. I'm going to put a 1 here. So really I'm just going to multiply 87.9645943 times 1 and then divide it by 12. Once I divide that number by 12, my circumference is now in feet. So once I divide 87.9645943 by 12, I get 7.33, and I'm going to keep the long number. I'm not rounding until the end. And now these are feet. Now I have to figure out how many revolutions this tire will make. So I take the 500 feet and I'm going to divide it by that circumference. And I'm going to round now to the tenths place. So once I divide this by 500 divided by that number, I get 68.209, so rounded to the tenths place, 68.2 revolutions. Now, more than likely on an SAT, they would just probably ask you how many full revolutions. So you might just say 68. They may not want you to round. Okay, so here it wants us to find the indicated measure. So in part A, they want us to find the length of the arc. So, and notice they've given us a diameter. So what I'm going to use is the length of the arc, or arc length, is equal to measure of the arc divided by 360 times, and since they gave me a diameter, I'm going to use the formula for circumference of pi d, because that's what they gave me. They gave me the diameter. Now the measure of my arc is the same as the central angle. So this measure of this arc is 75 degrees, but now I have to figure out how long it is as well. So the length of the arc is equal to 75 over 360 times pi times 9. Notice the instructions are keep your answer in terms of pi. Again, in the homework, it may say keep your answer exact, which is the same thing. So what I need to do here is simplify these fractions. So the first thing I can do is I'm going to simplify the 9 and the 360. So I know that 9 divided by 9 is 1, and then 360 divided by 9 is 40. So now what I'm at is length of the arc is equal to 75 over 40 times pi. I still can simplify some more. This is not in simplest form yet. I can divide 75 and 40 by 5. I can reduce that fraction a little bit more. So I can divide both of these by 5. This becomes 15. This becomes 8. So my length of my arc is equal to 15 over 8 pi. And these are in yards. You could also write the pi in the top. So these two answers that are here, this is exact or terms of pi. But if it would have said round to the hundredths, then what I would have needed to do was multiply 15 times pi and then divide it by 8. Once I do that, rounded to the hundredths place, 5.89 yards. And that would be the length of the arc using your pi button. So for the next one, we're not finding the length of the arc. They want us to solve for the circumference. So we're still using the same formula, but this time instead of putting it in as pi d, I'm just going to put a capital C there. So again, I'm going to be doing length of the arc, which is right here, the 60 pi. Notice they're meters. It's a linear unit. So this is the length of the arc. This is going to be the measure of the arc, because my central angle is 270. So the measure of my arc is 270. So equals 270 over 360. And then I'm just going to put here times by C. Now I'm also going to get out of, actually let me put this back as measure of the arc and then I'll fill it in. Let me put this in as measure of the arc. And now let me fill in all the numbers. So my length of my arc is the 60 pi. The measure of my arc is 270. And I don't know the circumference. This is what I'm solving for. Notice the instructions say leave it in terms of pi. So I'm going to need to simplify my fractions here. The first thing I always look for is whenever I have a 0 in the numerator and the denominator of my fraction, I can get rid of the zeros by dividing it by 10. So now I'm at 60 pi equals 27 over 36 times the circumference. I could still simplify my fraction a little bit more. I can divide them both by 9. So I could actually divide both of these by 9. This becomes a 3. This becomes a 4. So now I'm at 60 pi is equal to 3/4 times the circumference. I need to solve for c, so here's my algebra skills. All right, so then now I need to get c by itself. So what I need to do is divide both sides by 3/4. So remember, when you divide fractions, really what we're doing here on this side, because this simplifies, 3/4 divided by 3/4 just gives me the c that I was looking for. And then here what I need to do is 60 pi over 1 divided by 3/4. Keep, change, flip this. This will simplify. And then this one becomes 80 pi. So the circumference is 80 pi, and these were meters. Now, in this particular case, you could have divided 270 by 360, but if it gave you a decimal, then you needed to go back and do it all as fractions. Instead of showing this, instead at this step of 60 pi equals 3/4 c, soon as I see I have a fraction next to a variable, I take the reciprocal and write it on both sides. And then that simplifies, these all become 1s. And then now I get my c by itself, and then I multiply. Now, if it said to use your calculator, then you would do 80 times and hit that pi button, and you would get 251.33 meters. So when they want it in terms of pi, you're gonna more than likely get some fraction answers. But if it divides evenly, then go ahead and try it on your calculator. That is fine. All right, the next example, notice the instructions say to use your calculator. So notice this part A really looks like the previous example, but notice my length of my arc is a decimal. There's no pi here. So that's why I'm using my calculator. So again, I'm using length of the arc is equal to measure of the arc divided by 360, and then they want us to find the circumference. So I'm going to put just the c here because that's what we're solving for. So I'm going to fill in what I have. The length of my arc is 61.26. The measure of my arc is right here, same as its central angle, 270. And then times by c. So now, because they're just asking me to find c, and they said use my calculator, all I have to do is divide both sides by 270 divided by 360, or again, do that reciprocal thing. Multiply this by 270, and then divide it by 360. Once you do that, the circumference is equal to, and this said round to the tens place, to 81.68 meters, but to the tens place, 81.7. What I'm going to do is the same thing. Length of the arc is equal to measure of the arc divided by 360, but this time they want me to find the radius. So instead of putting a capital C here, I'm going to put the formula that has the radius in it. So let me fill in what I have. So this is the length of my arc. So I put in 10.5. the measure of my arc is going to be the 150. And then it's over the 360. And then I'm solving for the radius. So we're going to try to find the radius here. Now, I'm going to do this one in terms of pi and also using my calculator, even though the instructions said to use your calculator. So again, what I can do here is simplify the zeros. I can also simplify 15 over 36. I can divide them both by 3. So then I'm left with 10.5 is equal to 5 over 12. And then I still have the 2, the pi, and the r. And then I can simplify the 2 and the 12. Make this a 1 and a 6. So now I'm at 10.5 is equal to 5/6 pi times the radius. Now this is if it were in terms of pi. If not, you could have just done everything on your calculator ahead of time. So then what I could do is get rid of the pi, divide both sides by pi. So now I'm at 10.5 over pi equals 5/6 times the radius. Now, if you'd rather do this like this, step by step, times both sides by 6, you could do this. And then 10.5 times 6 gives you 63 over pi equals 5r. And then now we got to divide by 5, which is really like multiply by 1/5. And then you would get 63 over 5 pi. And that would be your radius in terms of pi. Now, if they didn't want it like that, technically you shouldn't put a decimal in a fraction, but 63 divided by 5 is 12.6. But again, this would have been better in terms of pi. However, it's said to round to the tenths place. So you're just going to divide 12.6 by pi, round to the hundredths place. 4.01 is hundredths place, but tenths place, 4.0. All right, next slide has the definition of a radian. Now, we're used to measuring angles in degrees. However, you can also use another unit of measure called a radian. So in a circle, when it has a radius length of 1, the radian measure of a given central angle could be thought of as the length of the associated arc with the angle. So notice this is going to be what I'm going to multiply by my degrees in order to convert it to a radian. This is just a simplified fraction. Same thing here. It's just the fraction simplified. So when I want to convert from degrees to radians, I'm going to take my degree measure and I'm going to multiply it by pi over 180. If I want to convert from radians to degrees, I'm going to take my radian measure and multiply it by 180 over pi. So an example is, let's say I wanted to convert 10 degrees to radians. All I would do is take 10, multiply it by pi over 180. Again, I could simplify. 10 goes into 10 once. 10 goes into 180 18 times. So in radians, it's just going to be pi over 18 radians. And then if we wanted to do, let's say you were given pi over 4 radians, and it said to convert it into degrees. So we'll multiply it by 180 over pi. the pi's cancel, and then you can multiply what's left. 180 divided by 4, and 180 divided by 4 is 45. You could have also simplified the 4 and the 180 before you multiplied, but again, it divided evenly. And then the last examples, I'm just going to take my degree measure, multiply it by pi over 180. I'm going to leave it as a simplified fraction. 15 goes into 180 12 times. Pi over 12 radians. And then if I want to go the other way, 4 pi over 3, 180 over pi. The pi's cancel. I can also simplify the 3 and the 180. And then I'm left with 240 degrees.